Now we are coming to the third problem. So here in this third problem it is given, so it is the 3 solid spheres each of a mass at 10 kg. So that is a solid spheres are there, that is each of a mass at 10 kg, and thereafter it is given and a diameter 0.2 meters. So that's why diameter is given, it is the 0.2 meters is also there. And here are placed at the 3 corners ABs of an equilateral triangle of a side 1 meter. So that's why that L is given, it is the 1 meter. Now you are supposed to find out what is the moment of inertia of the system about the axis AB. About the axis AB. So from that given data you have to draw the diagram. So this is the triangle is here, this the triangle is here, and here also now 3 solid spheres. That's why it is the 3 solid spheres each of a mass at 10 kg. So one is here and again another one is here and here also. Now it is the ABC, A, B, and this can be taken as a C is here, ABC, and its diameter is the 0.2 meter and L is equal to 1 meter. So that's why it is the equilateral triangle. And you are supposed to find out the moment of inertia. You are supposed to find out the moment of inertia about that one side, that is nothing but the AB. Here the equilateral triangle is taken. In this case also, just like in the previous problem, here also you have to apply the parallax theorem. Here again the two axes are appearing. One is about this AB. So that's why this is the axis of rotation. To indicate it is the axis of rotation, that's why we give such type of arrow like this. And the next one is that is the diameter is also there. Diameter is also there. So this is a solid sphere and its mass is the 10 kg. That's why when this triangle is rotating like this, when this triangle is, when these 3 masses are rotating like this, in that case, that is the each and every solid sphere is rotating about its own diameter also. Is rotating about its own diameter also. So they are rotating. Suppose if at all you are considering a sphere here like this, suppose when it is rotating, this is the triangular frame is rotating like this. When it is rotating, if you give a mark at this point on this sphere, when it is rotating, that mark comes to this point, and again on rotating the mark comes to this point, and again it is coming to this point, and again it is coming to point. So that's why that mark is rotating, that is a complete revolution is the 360 degrees. So because of the reason we can say it is rotating about its own diameter also. About its own diameter also. But there are the two, even though there are the two axes are there, you are going to find out the moment of inertia about this given axis AB. And here also, just like in the previous problem, here we are finding the moment of inertia of each one, that is the IA and again the IB and again after that IC. That will be the total moment of inertia of that entire frame. Now it is the IA is to be taken. So for that IA, it is the, we are applying that parallax theorem. Already you know that parallax theorem is nothing but the I is equal to INA plus MR square. This is the formula. According to that, this is the IA is equal to INA. INA means it is the 2 by 5 MR square. You remember this one. This is the 2 by 5 MR square. This is the moment of inertia of the solid sphere about its diameter, which is nothing but its natural axis also. Which is nothing but its natural axis also. IA is equal to 2 by 5 MR square is there, and thereafter it is the M into distance square. So here this given axis AB and the diametrical axis of that sphere both are coinciding. So as the both are coinciding, that's why we are taking this is taken as the 0, because there is no any distance of separation between the two axes. Those two axes are the given axis AB and the diametrical axis of that sphere, both are coinciding. That's why the distance of separation between them is the 0. So it is the 2 by 5 MR square is there. And when you are coming to this, that is the IB, that also will be the same. That is also 2 by 5 MR square is here. And it is the M into 0 to be taken, because A and B are along the same line like this. That's why here also that diametrical axis is coinciding with the given axis AB. So 2 by 5 MR square plus M into 0 is there. Next again, when you are coming to this IC, so for that what we have to take, this is the perpendicular distance. This is the perpendicular distance. So these are the two axes are there, and here it is a 1, and this becomes a 1 by 2, and you have to find out this altitude. So for that what we are taking square root of 1 square minus 1 by 4. So that becomes it is the root 3 by 2 is here. That becomes under root 3 by 4, it is the root 3 by 2 is here. So that's why this r can be taken as the root 3 by 2 meters. Now when you are coming to this IC, and here the diametrical axis, this is the diametrical axis, this diametrical axis and again this given axis AB are not at all coinciding. So and again they are maintaining some distance of separation also. Because of that reason we have to take it is the 2 by 5 mr square, 2 by 5 mr square plus me is there, and here the distance of separation is existing, so that's why it is the root 3 by 2 whole square is there. Root 3 by 2 whole square. Now the moment of inertia of that total frame about the given axis AB, that is the IAB is equal to, it is the IA plus IB plus IC. These are the moments of inertia of each body, each sphere about the given axis. So we are combining all of them. So in that case IA is equal to 2 by 5 mr square. 2 by 5 mr square means it is nothing but the 2 by 5, and m is given that it is the 10 kg, and r is that is the 0.1. So that's why 0.1 whole square means it is the 10 to the power minus 2. So it is the 2 by 5 and it is the 10 to the power minus 1 is here, 0.2 by 5. So that's why it is the 2 into 2 by 5 mr square, 2 by 5 mr square plus IC. IC means it is the 2 by 5 mr square is already there. So that's why 3 to be taken. Because in IA, one is this one, and another is this one. So that's why 3 into 2 by 5 mr square plus me is the 10 kg, and again 3 by 4 to be taken, and overall that becomes it is the, that answer is given 7.62 kg meter square. So you can verify it later, that is 7.62 kg meter square. This is the procedure in solving this type of model. So once again I tell you, now you are given the 3 spheres are there. These 3 spheres are the, now you are supposed to find out, these are placed on the vertices of an equilateral triangle, and you are supposed to find out the moment of inertia of the about the given axis AB. And here that given axis AB and the diametrical axis of that sphere, they are coinciding in these two cases, but they are not coinciding in these two cases. That's why it is the IA, IB, IC, and it is the total moment of inertia that is cleared. Next one. So third problem is completed. Now we are coming to this fourth problem. In this fourth problem, the disk of radius r and thickness r by 6 is there. So the disk of radius r, so this the disk is here and its radius is the r is here, and again its thickness is given that is the r by 6 is also there, and thereafter it is has a moment of inertia I, its moment of inertia I about its own axis. Next, it is melted and recasted into a solid sphere, and the moment of inertia of that sphere about its diameter will be. So that's why it is the moment of inertia is the I in this case. Now it is melted and recasted into a solid sphere. What is the moment of inertia of the about this diameter will be? So that is the point. Now here it is the first case. The first case we are taking it is the disk. So in this case it is the, we have taken it is the disk is here, and it is melted and recasted into the solid sphere. So that's why in the second case it becomes a solid sphere like this. So here what will be the moment of inertia of this solid sphere about its natural axis, that is nothing but the diameter. In this case also what we have to see, that is first of all these masses are same. These masses are same. Here the formula is that can be taken, I is equal to INA for the disk is. So that is it is rotating about the moment of inertia about its own axis. About its own axis means it is the mr square by 2. It is the mr square by 2. And again here in this case it is the INA, that is nothing but the diametrical axis. It is the 2 by 5 and m dash, and again it will be the m dash, so m dash is not required. So that's why m r dash square is there, because the mass doesn't change here in both cases. When it is melted and recasted, there is no change in the mass. Everything will change except the mass. So that's why here it is the mass will be constant, but the radius will change. So that's why r dash square is taken. Now here we have to give the relation in between that r and r dash. And for that we have to start from here, that is the first equation we are taking, this is the second equation we are taking to find out the relation between the r and r dash. So we have to start from that, that is the mass of the disk. Mass of the disk, and again this mass of this solid sphere, and both are same because this disk only that is melted and recasted into the solid sphere. That's why both are same. In this case, mass of the disk means it is the density is there, rho, and again the volume. Volume is nothing but the area, and again the thickness is there. So density into volume. And thereafter here also mass of the sphere means again the density because of the same material. Because of the same material, rho is here, and here that volume is nothing but the 4/3 pi r dash cube is here. 4/3 pi r dash cube is here. So that's why rho will be cancelled, and a, in place of the a, what we are taking, it is the pi r square. And thickness is nothing but it is the r by 6 is there. So that's why area into thickness, that gives the volume of that disk. So that's why pi r square into r by 6 is there. And thereafter it is the 4/3, and pi is also there, and r dash cube. Now you have to find out that r dash cube. And in this case, pi will be cancelled, and the 3 is here. So that's why it is the r cube is equal to, that is the 2r dash whole cube. That is r cube is equal to 2r dash whole cube on solving. And that becomes, it is the r dash, 2r dash is equal to r, and implies r dash is equal to r by 2. Its meaning is after melted and recasted, that is the radius of that sphere becomes, it is half of the radius of the disk. So that's why it becomes now only the r by 2. It becomes only that r by 2 is there. Now we are coming to this, that is the I dia is equal to 2 by 5, and m is here, and r dash. In place of the r dash, what we can apply, that is the r by 2 is there. So that's why it is the r square by 4. So 2 by 5 mr square by 4. Now here this answer is to be given should be in terms of that I only, because already you are mentioned this, the INA is nothing but the I. So that's why mr square is equal to 2I. Mr square is equal to 2I. So that's why here it is taken 2 by 5. In place of the mr square, I to be taken, and thereafter it is the so it is the mr square, 2 by 5 mr square. Now it is the disk is there, mr square by 2, and here it is r dash is equal to r by 2 and r square by 4. So it is the 2 by 5 mr square by 4. So 2 by 5 is there. In place of the mr square, 2I to be taken, 2I to be taken, and thereafter 4 is here. The answer becomes I by 5. That's all. The answer becomes I by 5. Once again I tell you, now here it is the disk is taken, and again the solid sphere. This is melted and recasted into the solid sphere. So that's why there won't be any change in the mass, only the change is in the radius. So that's why on equating the masses of both the objects, that's why here both the bodies, here we are getting that relation between that radii in between this, that is the r dash is equal to r by 2. Now you are applying that r dash is equal to r by 2 here. That becomes, it is the 2 by 5 and r by 2 r square by 4, and in place of the mr square, what we are applying, 2I. That's why we can write it is the from 1. So from 1 we have taken the help of the first equation. So that's why from 1 to be taken. So 2I is there, and 2 by 5 and 2I. So that becomes I by 5 will be the answer. So that is the problem. Fourth problem is completed. Now we are coming to the fifth one.